543 nanometers. So we set our machine at 543, and then we put these samples in there. We had a sample that had 225 milligrams per liter. We have a sample that has 110 milligrams per liter. One that has 22.5 milligrams per liter. And then at 0, it still should be 0. So we have basically 4 data points on our line. And when we graph it, we could actually put it on, we could put it on a graph. And that's actually what it comes out looking like. That's real data that I graphed. So at that high concentration, the first one, we had an absorbance of 1.852. When we took 110 milligrams per liter, it was 0.968. Does that make sense? Well, this number is about half of that number, so it makes sense that that number is about half of that number. In other words, there's half as much stuff, so it should have absorbed half as much light. Does that make sense? Okay. Then we have a real small sample, 22.5, and it's got an absorbance of 0.185. So once we get that information, then we have to calculate and solve for our slope. Slope is rise over run, change in y over change in x. Let me see if I've got a red marker, because that green is not going to show up on film, I don't think. So we need to figure out what the slope is of this line that I graphed for you down here on the bottom of the page. So if slope is equal to rise over run, then we need the change in x over the change in y. So our highest y value is 1.852 minus 0.185. There's a 2 right there, 1.852. Minus that, so that's the change in y, and we're going to divide that by the change in x at that same section on the line, so it's 225 minus 22.5. So whatever I get there is going to be my slope. Anybody on the calculator?
Yeah, I'm good.
Okay.
The top number is 1.667.
Okay.
And the bottom number is 202.5.
Okay, and when you divide 1.667 by 202.5, what do you get there? It'll be a small number. We're dividing 1 2/3 by a huge number, so it's going to be a real small number.
0.0082.
Okay, so the slope of my line is 0.0082. So when I'm calculating the slope of this line, the rise over run of my graph down here, it's got a slope of 0.0082. Now, is that a big number? No, that's not a big number. It is sort of misleading looking at this graph, because if you just look at this graph, it's like, no, that thing's pretty steep. But is it really that steep? No, it is not. This unit goes all the way out to 225 on this axis. This axis over here don't quite make it to 2. So I'm comparing apples and oranges here, if you want a scale-to-scale balance here. So no, this line is not that steep actually when you look at it. If we were to run this up to 200 to make it equal, you know, what we end up with a line is a line that's like this instead. So the slope is not actually that big, but for effect, to kind of give us a kind of indication of where things are at, we can do it this way. Okay, then I give you some patient samples. Once we have solved for the slope of that line at that wavelength, then we can go back and we can solve for as many unknowns as you might want. Okay, I've got 4 patients here. So patient number 1, if I know that the concentration is equal to the slope, the absorbance divided by the slope, then for patient number 1, 0.678, and I would divide that by my slope of 0.0082, tell me what kind of number I get there.
Excuse me, sir.
I've divided that absorbance for patient number 1 of his serum sample, divided by the slope of my graph, of my line, and what do I get when you do this?
Let me see. $82.68.
82.68, so 82.6 something. Your math teacher way back in the day always taught you to go back and look at your answer and see if it was reasonable. So if we did our math, it should be reasonable. So if we have an absorbance of 0.678, that's somewhere up in here, and I work back over here to about where 82 would be at, and this is going to be 0.6, so it's close to 70, somewhere in there, Is my answer reasonable? Yes, that's a reasonable answer. If I came up with an answer like 182, no, that answer would not be reasonable on my graph.
Make a lot easier.
So how can you tell if it's reasonable or not?
Okay, because see, I'm looking at these known points. Now, this is stuff we actually mixed up, put it in the machine. We know what the absorbance is. So I know that if I put 225 milligrams of XYZ per liter of water, I know I'm going to get an absorbance of 1.8 something. Okay? So when I put this sample in and I get 0.678 on my absorbance over here, that's right about here. If I follow that back over to where it touches the line, that's about where 82 is going to be. Because 50 is here, 70 is here, so 75, 80, 82. So yes, my answer is reasonable.
I got you.
And if you do that for each of these other points, take these home and do these, you'll find out it's going to get pretty close to right.
I have a question.